Now we're going to look at some half angle formulas, and these are very similar to the formulas we've seen before for double angle, but also the power reducing. If you notice our power reducing formulas, because of that sine squared, if you take the square root of these things, we end up with angles that have this. If I take the square root, this is a theta, and this is a half of that. You know, if we reverse the process, so it looks very similar to what we see on the last page, theta and half of that. Once we take the square root, so it's coming from these power reducing formulas. It's just that when we take a square root to solve, and we're isolating the sine, the cosine, the tangent, when we're taking the square root to solve, we don't know if it's positive or negative. So that's where we're seeing this plus minus in this formula. And the reason why we have the plus minus in the formula is because we, meaning the people doing the problem, doing the work, have to know which quadrant we're dealing with, right? The quadrant is going to determine the plus or the minus. So we have to know that if I was in if I had a 300 degree angle and I'm taking half of that, I'm a 150 degree angle, I'm in quadrant 2. So tangent will be negative, sine will be positive, cosine will be negative. So the angle is going to determine which one of these we take. It's not that there's going to be two possible answers, or that there are multiple outputs for this input. That's not the case. It's just that we need to know which one it is based on the angle that we're dealing with. Alright, so find the exact value of the cosine of 112.5 degrees. Well, 112.5 degrees is half of a known angle. So we're going to use this plus and minus the square root of 1 plus cosine of double that angle. Right? So if we're dealing with a half angle, this is going to be plus and minus the square root of, this is cosine of a half of a known angle. So cosine of 1 plus. So 1 plus the cosine, which, who is this half of? This is half of 225 degrees over 2. Now, we don't need the plus minus because 112.5 degrees, if you think about it, this is 180 degrees. This is 90 degrees. So I know 112 is somewhere in here. So 112.5 degrees is in quadrant 2. Right? And in quadrant 2, cosine's the x-coordinate. Right? We're to the left of the y-axis. So in quadrant 2, cosine is negative. Alright, so I know I don't need the plus and minus. I only need the minus because I'm in quadrant 2. Alright, now I just plug in. I get 1/2 plus, I'm just split it in pieces, the cosine of 225 degrees. Alright, what's the cosine of 225 degrees? Well, again, if you think about your unit circle, there's 225 degrees, all right, and the cosine is the x-coordinate, so negative root 2 over 2. So this is negative square root of 2 over 2, all right, for this part. The cosine of 225 is that, but notice we still have a divide by 2, so divide that by 2, and we're going to end up with the square root of 1/2 plus the negative square root of 2 over 2 divided by 2 will be the negative square root of 2 over 4. Alright, and now I'm going to write that as, instead of plus and negative, I'm going to write that as just minus. And then we need to get a common denominator here. So we're going to get a common denominator of 4, and then 1/2 is the same thing as 2/4 minus 4 here. We got a root 2, so we don't have to change it. And we end up with the square root of 2 minus root 2, 2 minus square root of 2 over 4. Okay, now we can split that up because 4 is a perfect square, and we end up with the square root of 2 minus the square root of 2 all over 4. Alright, now that, square root of 4 is 2. When I'm taking it out of the radical, I don't need the radical. I mean, I gotta take the square root, so square root of 4 is 2. Basically, I'm splitting this up into this over the square root of 4. Okay, square root of the top over the square root of the bottom. It's just the square root of the bottom is a perfect square, so I can take its square root. Alright, now this is negative. As soon as I wrote that, I took the negative away. this is negative, so I end up with that number. Okay, negative square root of 2 minus square root of 2. This square root is underneath this radical, so do make sure you extend it far enough. And then the 2 is not under the radical. All right, now let's verify. Let's show that it is true. How are we going to show that? Again, I'm in degree mode, so make sure you're in degree mode when you do this. Okay, I'm going to type in the cosine of 112.5 degrees. All right, I get that number. And then I'm going to take the negative square root of 2 minus the square root of 2. Close, close, right? That closed that square root, that closed that overall square root, divided by 2. All right, and then there's the same thing. So this is the exact value, and this is, again, not a perfect, what should I say, it's not a special angle, but it is half of a special angle. Okay, so when the thing that you're trying to find is not a special angle, but it is half of a special angle, that's when you would use the half angle formula. I have half of a known special angle. So notice inside the formula, that thing gets doubled back to a known special angle. And that's when we use this.